The strategic landscape of World War II is almost universally described as a clash of massive industrial systems, characterized by the competitive output of coal, iron, steel, and oil. Yet, beneath the grand tallies of industrial tonnage lay a series of highly specific chemical and geological dependencies that acted as absolute gates on global military capacity. The most critical of these silent choke points was the industrial metallurgy of aluminum. By 1939, the transition of military aviation from timber and fabric biplanes to all-metal, stressed-skin monoplanes had made aluminum the foundational metal of global air power. From the agile Supermarine Spitfire and the mass-produced Messerschmitt Bf-109 to the lumbering heavy bombers like the Boeing B-17 Flying Fortress, every modern combat aircraft was physically shaped from high-strength aluminum alloys, specifically duralumin. Yet the physical synthesis of this essential metal was governed by an unyielding law of chemical engineering, a law that bound the entire global aviation industry to a single, isolated geological singularity in the subarctic wastes of Greenland. To understand the absolute strategic leverage of Greenland during the global conflict, one must examine the physics of the halt process, the universal chemical method for extracting pure aluminum from raw bauxite ore. While bauxite is abundant in the Earth's crust, the extraction of metallurgical-grade alumina, aluminum oxide, is only the first stage of the process. To convert this white alumina powder into metallic aluminum, it must undergo high-amperage electrolytic reduction inside massive carbon-lined smelting pots. However, aluminum oxide possesses an incredibly high thermal melting point of exactly 2072 degrees Celsius. Attempting to melt alumina directly to pass an electrical current through it requires an astronomical expenditure of energy, rendering mass industrial production physically and economically impossible. To solve this thermodynamic barrier, the halt process relies on a chemical catalyst, cryolite, a rare sodium aluminum fluoride mineral. When alumina is introduced into a molten bath of liquefied cryolite, a remarkable thermodynamic reaction occurs. The cryolite acts as an active solvent, dissolving the aluminum oxide and dropping the melting temperature of the entire bath from over 2000 degrees Celsius to a manageable 950 to 1000 degrees Celsius. This massive reduction in temperature reduces the electrical energy requirement of aluminum smelting by more than 50%, making the continuous industrial electrolysis of aluminum a physical reality. Without cryolite, the carbon anode pots would burn out in minutes, the electrical grid of any industrial power would be instantly overloaded, and the mass production of combat aircraft would grind to a halt. While synthetic alternatives existed, the industrial chemical sector of 1940 was incapable of manufacturing synthetic cryolite at the scale, purity, and low cost required to sustain the explosive growth of wartime military aviation. This chemical reality transformed an obscure fjord in southwestern Greenland into the ultimate geopolitical choke point. Located on the rocky shores of Arsuk Fjord near Cape Desolation, the tiny settlement of Ivigtut held the world's only commercially viable, high-purity natural deposit of cryolite. For centuries, geological forces had concentrated this icy, translucent mineral into a single massive, open-cast quarry. The Ivigtut mine was not merely an important resource, it was a total global monopoly. Every pound of high-quality aluminum, refined by the Aluminum Company of America in the United States, by Alcan in the massive Arvida smelter in Quebec, Canada, and by British aluminum refiners, was chemically dependent on the continuous shipping of natural cryolite ore from the docks of Ivigtut. The control of this single pit, measuring only a few hundred meters across, was the invisible pivot upon which the entire air war over Europe and the Pacific was balanced. The fragile equilibrium of global cryolite logistics was shattered on April 9, 1940, when Nazi Germany launched Operation Weserübung, invading and occupying Denmark in a matter of hours. This rapid collapse created an immediate, terrifying geopolitical vacuum in the North Atlantic. Greenland, which had been administered as a highly isolated and protected Danish colony since the early 18th century, was suddenly cut off from its metropolitan government in Copenhagen. The German occupation of Denmark meant that the Danish king and cabinet were operating under direct Axis duress if the puppet Danish administration were forced to order the colonial authorities in Greenland to ship Ivigtut's Cryolite exclusively to Axis-controlled ports, or if German naval forces occupied the island to secure the mine, the Allied aircraft production lines would face an immediate, fatal raw material crisis. In Greenland's capital of Godthaab, the Danish governors, Eske Brun of North Greenland and Axel Svanø of South Greenland, recognized that they were in a position of extreme vulnerability. Executing a brilliant and highly risky diplomatic maneuver, Brun and Svanø invoked an obscure 1925 Danish colonial law that allowed local governors to assume emergency powers if communication with the mainland was severed. Declaring Greenland an autonomous, self-governing territory under the temporary protection of the United States, the governors severed all administrative ties with occupied Copenhagen. Yet, the physical protection of the Ivigtut mine remained an unresolved crisis. The territory possessed no military forces other than a handful of local hunters, while the mine itself was completely defenseless against a single determined German surface raider or U-boat crew. The strategic threat was not lost on Great Britain or Canada. In May 1940, as the Battle of France raged, Canadian Prime Minister William Lyon Mackenzie King and his military staff recognized that if the Ivigtut mine fell, the Canadian aviation sector, specifically the massive Alcan smelting complex at Arvida, Quebec, would be paralyzed. Canada quietly mobilized Force X, a heavily armed military expeditionary force tasked with sailing to southwestern Greenland, occupying Arsuk Fjord, and seizing physical control of the Ivigtut quarry to guarantee the flow of cryolite. However, this planned Canadian military intervention triggered immediate diplomatic alarm in Washington. Its state's President Franklin D. Roosevelt and Secretary of State Cordell Hull viewed any unilateral Canadian or British military occupation of Greenland as a direct violation of the Monroe Doctrine. Under the Monroe Doctrine, the United States was ideologically and strategically committed to preventing any European or non-American power from expanding its military footprint in the Western Hemisphere. Although Canada was a North American nation, its status as a British dominion meant that a Canadian occupation of Greenland could provoke direct German military retaliation, bringing the European war directly to the doorstep of the American continent. The United States government made it clear to Ottawa that Washington would assume sole responsibility for the geopolitical security of Greenland, initiating a high-stakes diplomatic standoff over who would guard the most valuable chemical pit in the world. To preempt a Canadian military landing and secure the flow of cryolite without provoking an open diplomatic rupture, the Roosevelt administration executed a swift, multi-pronged diplomatic and naval intervention in May 1940. The first American foot on Greenland soil was not a soldier, but a young and highly capable diplomat named James K. Penfield, who was dispatched aboard the U.S. Coast Guard cutter Comanche to establish the first United States consulate in Godthaab. Penfield's mission was to coordinate directly with Governor Eske Brun and Axel Svanø, formalizing an economic and security pact that would bypass the occupied Danish government in Copenhagen. The United States agreed to purchase the entire output of the Ivigtut cryolite mine, providing the autonomous Greenland administration with the vital financial revenues and consumer supplies needed to survive its isolation. By April 1941, the legal framework of this security arrangement was finalized, through one of the most unusual diplomatic agreements of the war. Henrik Kaufmann, the Danish minister to Washington, boldly refused to recognize the authority of the German-controlled government in Copenhagen. Operating as a self-styled independent representative of the Danish king, Kaufmann signed the Agreement on the Defense of Greenland with U.S. Secretary of State Cordell Hull on April 9, 1941, exactly 1 year after the German invasion of Denmark. The treaty granted the United States the explicit right to construct, maintain, and defend military airfields, seaplane bases, radio stations, and meteorological outposts across the island. The Danish government in Copenhagen instantly declared Kaufmann a traitor and ordered his dismissal, but Washington ignored the occupied regime, recognizing Kaufmann as the sole legitimate voice of free Denmark. The physical defense of the Ivigtut mine was immediately assigned to the United States Coast Guard. The Coast Guard organized the Greenland Patrol, a fleet of heavily reinforced, ice-strengthened cutters such as the Northland, Comanche, and Southwind, specifically designed to operate in the treacherous berg-filled waters of the sub-Arctic. At Ivigtut itself, the Americans constructed a specialized naval station, installing coastal defense batteries, anti-aircraft guns, and minefields to protect the entrance of Arsuk Fjord. A small local military force known as the Northeast Greenland Sledge Patrol was organized, consisting of Danish and Greenlandic hunters who patrolled thousands of miles of uninhabited coastline on dog sleds to detect any German attempts to establish secret weather stations or landing parties. The U.S. Army Air Forces rapidly began construction of massive air bases in Greenland, codenamed WWII West 1 in the south and WWII West 8 in the west. These bases served a dual strategic purpose. Not only did they provide air cover for the Ivigtut Cryolite mine and the coastal shipping lanes, but they also acted as the critical stepping stones for the North Atlantic ferry route. Thousands of American-built bombers and fighters, flying from factories in the Midwest, refueled at WWII West 1 before leaping to Iceland and Great Britain, proving that Greenland was not merely a passive resource quarry, but the vital air bridge that made the Allied strategic bombing of Germany physically possible. To fully appreciate the strategic leverage of the Ivigtut cryolite mine, one must move past geopolitical narratives and analyze the unyielding quantitative mathematics of wartime aluminum logistics. During the critical years of 1940 to 1944, the global demand for aluminum experienced an exponential surge. In 1939, the United States manufactured approximately 163,000 metric tons of aluminum. By 1943, under the pressure of President Roosevelt's Victory program, which demanded the production of 50,000 aircraft per year, American aluminum output skyrocketed to over 840,000 metric tons. A parallel expansion occurred in Canada, where the Alcan refinery at Arvida grew to become the largest single aluminum smelter in the world, producing over 450,000 metric tons annually. This combined Allied output of 1.3 million metric tons of aluminum was the physical substance that won the war in the air. Yet, this massive production line was governed by a strict chemical consumption ratio. For every metric ton of metallic aluminum produced via the Hall-Héroult process, approximately 50 to 60 kilograms of high-purity cryolite is permanently consumed. This consumption occurs because the intense thermal and electrical environment inside the smelting pots causes the cryolite solvent to slowly vaporize, degrade, and absorb into the carbon linings, requiring a continuous daily replenishment of fresh cryolite ore to maintain the electrolytic reaction. To sustain an annual production of 1.3 million metric tons of aluminum, the Allied smelters required a continuous guaranteed supply of approximately 65,000 to 78,000 tons of high-purity cryolite every single year. This is where the mathematical what-if becomes terrifyingly clear. Had a German U-boat wolf pack or a highly trained team of Abwehr saboteurs successfully infiltrated Arsuk Fjord and destroyed the specialized processing plants, power generators, and harbor cranes at Ivigtut, the flow of natural cryolite would have ceased instantly. In 1940, the United States possessed a strategic stockpile of natural cryolite that was calculated to last for less than 4 months of peacetime production rates. Under the explosive demands of wartime manufacturing, this stockpile would have been depleted within 45 days. The Allied aluminum industry would have been forced to rely entirely on synthetic cryolite, a transition that would have triggered a catastrophic industrial bottleneck. In 1941, the United States synthetic cryolite industry was in its infancy, capable of producing only a fraction of the required tonnage. Furthermore, the synthesis of cryolite requires massive quantities of fluorspar and hydrofluoric acid, highly hazardous chemicals that were already strictly rationed for high-octane aviation fuel refining, atomic bomb research, and steel production. Had the synthetic chemical sector been forced to divert its entire capacity to smelting catalyst production, it would have starved these other vital military programs. Even if synthetic cryolite were used, its lower purity and higher silica content dramatically accelerated the erosion of the smelting pot's carbon liners, reducing pot lifespan by up to 50% and causing frequent catastrophic smelter failures. Mathematically, a total loss of the Ivigtut mine in late 1940 would have caused an immediate, estimated 40 to 50% drop in Allied aluminum smelting capacity during the critical year of 1941. To put this in perspective, a 40% reduction in aluminum output translates to a loss of approximately 200,000 tons of the metal. Since a heavy bomber like the B-17 required approximately 10 tons of aluminum and a fighter like the Spitfire required 2 tons, this deficit would have translated to a physical loss of over 10,000 heavy bombers or 50,000 fighter planes. The Allied air forces would have been starved of their physical wings, delaying the invasion of Europe, crippling the strategic bombing campaign against Germany, and giving the Luftwaffe time to recover. The tiny, snow-swept open pit of Ivigtut was, in the truest economic sense, the single chemical key that unlocked the skies of Europe.